What's up guys? This is Joe Jet, the mind behind Jet Set. Today I am going to be going over a new interesting kind of bend. Yeah, it's going to be a bend, but I'm not going to build it into a different case. I'm going to keep this bend in its own case because it's incredibly unique. I've never seen anything quite like it. Now, one of my favorite finds whenever I go out to Goodwills and thrift stores and things like that is just looking for like robotics or any sort of animatronic, you know, like animals or people or things, you know. And I came across this gem, just this absolute beautiful gem of a toy. It's a life-size, realistic cat, and it's from a very long time ago. Actually, I don't think it... Hold on a second. I might be thinking of something else. Well, 2006, not super long ago, but long enough ago to have a lot of fun and be able to do things with it. I already did all the skinning work, but here he is. This is how he looks without his skin, without his decency or his demeanor, without his dignity. This is a cat. So I've already taken the liberty pretty much of skinning him because I had already experimented with him before. There are a couple of bend points in there. I need to revisit him because it's been a while. I put him down to go finish the sequencer. But you know, I wanted to come back to him and I kind of wanted to do a video on him. Now, normally it's really hard for me to do any sort of videos on what I create because I never have any sort of plan when I go into them. I can't, like, I don't just like sit down and I'm like, alright, I'm going to take this apart. And then I'm going to do a video on, you know, exactly what I'm going to do and how I'm going to do it and, you know, my process throughout the whole way because it's always changing, man. I just, like, things come to me as I'm going along and, you know, sometimes I'll have a better idea and I'll go with that instead of trying to make my old idea work and then I end up with something that I'm not happy with and I just don't want to go through that, man. It's a lot of work. I'll give you a brief demonstration of what he does. He's an animatronic cat, you know, like he does what animatronic cats do. Well, these tinfoil bits on his head are touch sensitive. They're touch sensitive, so when you rub them, he'll start purring. Oh yeah, and you can feel his body purr too. And there's something you can do to, like, piss him off, and I don't know exactly... I haven't quite figured it out yet. I'm not good at pissing animals off in real life. I don't want to... He seems to like that. Let's tear him open and let's re-find his beauty marks and fun spots and stuff, and we'll see what we can choke out of him. So, got into the circuit. After getting his old side bit off, I had completely forgotten as well that on this circuit in particular, there are these pin casings basically that you just, you know, plug stuff into and make it way easier. So yeah, but in order to get the circuit board out of there, I had to unplug the pin things and pull this board out, unlatch them from their loops and their tracks on the case, and plug them back in. And now he's a working order boy. He's doing what he's supposed to do. And we're going to change that very quickly. But like I said, I was working on this a while ago. Going back to it, I see that I've got two leads here. I usually choose blues and greens for my potentiometers, positives and negatives. Green positive, blue negative. And this yellow one, I don't really remember what that's supposed to be. So I'm just going to prod around for a bit and reacquaint myself with the board. Maybe try a few different potentiometers up to this. If I remember correctly, this is a stutter, basically, so it'll like stutter his motor. We'll see. We'll see what happens. Let's see what a 500K pot will do. He's already gone crazy. It seems to just put him in a loop.
Oh, there we go.
Alright, so it looks like the yellow wire that I had put in here is the motor speed. And that's the yellow as the negative, so that's yellow with the green as positive on the 500K potentiometer. There's not a very big window, though, of activity, so I think I'm going to go down a potentiometer. Maybe try we'll try a 50K. We'll see what a 50K does. I know it's a drastic drop, but if it doesn't do anything, we'll just go up to 100, and then we'll try a 250. It's got to be one of them. And we can always get like a trim pot to adjust if needed to get it to where we want it to be. Oh man. Let's connect the other side of the pot to the green lead and see what that does. Oh yeah, 100K is where it's at. So I'm not sure if I want to keep his cat body. I mean, it's a really tough call to make because I love the body. It's really like it's just ridiculously realistic how the joints all like move and sit together and stuff like that. But I'm thinking it'd be really cool if I could somehow just have like take his chest part and remove the whole bottom half and everything. Just keep his arms, not his arms. Jesus, no.
Remove his arms
and legs, and so just like basically keep his head and his chest part. And maybe build it into, like, put it into something else. So I could have something else with, like, an animatronic screaming cat head coming out of it. So, you see where I have this wire attached on the top of this resistor? This yellow lead is one of the ones that controls the motor when I had it connected to this green one. However, I found that this yellow one also controls the motor with the top of this resistor right next to it. Yeah, I think it's actually a capacitor. C18. Oh my god. Oh my lord. Oh yeah, so actually that's a capacitor. C18. So yeah, so the top of this capacitor and this one right here, TP1 I believe, those also control the motor, so I don't have to connect this one to the green one. I can just leave the green one controlling the pitch with the blue one. So attached to control the motor, I've got it going to a 100K resistor and a 200K resistor just so I can fine tune it. Anyway, there's a bit in it that will not cooperate. So we've got plenty of really good little bend points on the cat, which is cool. I did a little research. I was looking up because I want to install one of the LTC 1799 chips that I got from circuitbenders.co.uk. I'll put it down in the description or wherever. It's a precision oscillator, basically, is what it is, and it's like a skeleton key for circuit bending, pretty much. It basically takes anything that you only have like one or two little bend spots with, or even if you have many bend spots with it, and you can just hook this precision oscillator up to it and do a whole bunch of really cool things with it. So I was doing a little research, and I was like, okay, so I want to know kind of what the chip is on the board that's on the cat. So I did a little research into it. It looks like the board that the cat is using, or the chip on the cat's board is the only chip on the board. It's the FAN, F-A-N 8100N, which I did a little research and I found the pinout for it. And it's a low voltage 2-channel DC motor driver. Huh. And so basically this is just the pinout for it. It's always good to, if you crack open a toy or an instrument or anything and you see chips on there and you don't know what that chip is, go online, look up the pinouts for it, and it will tell you exactly what every little pin on that chip does. So if you want to just kind of fine-tune whatever you're trying to do, or if you want to know what you're messing with so you don't possibly risk ruining, crashing your toy or your emotions, then yeah, you can just look up the pinout and it's really easy. So this is the pinout I have for the FAN 8100N. So you've got 3 pins and then a really fat energy pin right there in the middle, and then 3 others, and it's mirrored on the other side, of course. So we've got the first 3 pins. This is this is for a motor. You've got reverse B, forward B, out 2B, and then ground, out 1B, PVCCB, which is basically supply voltage for the B side of the chip, and the VCC, which is positive. On the other side, it's kind of the same thing all the way down. You've got reverse A, forward A, out A, ground, out 1A, PVCCA, which is the supply voltage for the A side, and D1A, which connects to a diode. I did the research. It connects to a diode, basically. It goes to a diode. It's controlling the direction of the current. So you can use your own pinouts to, well, not your own pinouts, at least you didn't really create the pins, but you can use pinouts basically to just better tune whatever you're trying to do. Now, this was the other thing that I had done. So this is the pinout I have for the LTC 1799 precision oscillator that I'm going to be using, hopefully. If I don't use it, then I will have it wired and ready so I can use it with another toy. I don't know, we'll see what it does with this. I don't know what it does, that's circuit bending. You don't know what anything does, it just does things whenever you touch things to things sometimes, but sometimes it doesn't. Sometimes it crashes them and then you just suck and you die, and then that's it. That's all there is to it. Yeah, LTC 1799. Incredibly easy. Very simple. Very simple. I'll go over it with you. And I have them right here. Now, this chip is the size of a grain of rice. It's so small that you need either incredibly steady hands. You need really heady hands. No, you either need really steady hands to solder it, or special equipment of some sort that I don't really know much about. But basically, when you order it, where I ordered mine was from circuitbenders.co.uk. When you order it, it'll show up. You can get it a couple ways. You can get it with the pins for, for surface mount, whatever. And you can get them like this, which is how I got them. I don't know how well you can see that. I'm gonna try and keep it center focus. See if I can't somehow telepathically label everything on this board. This little chip. So what this is basically is it's the LTC 1799 chip on the bottom. This little black bit is the one that's the grain of rice size. And then it's got a trim pot up here for some fine tuning. So this is the pinout we have for it. This top hole in the top corner, I'm just going to go down 1, 2, 3, 4, and then up from the bottom corner. 5, 6, 7, and 8 is going to be this top corner. So 1, this connects to a 5-volt power source. The LTC precision oscillator, the LTC 1799, this chip basically functions on a 2.7 to 5.5 volt power supply. Any more than that, you'll fry it. So you want to make sure that when you go to use it, you're turning off your device or your machine or whatever, testing, you're using like a multimeter or something to find some, point on the board that gives you a range between 2.7 and 5.5 volts. Just better safe than sorry. That's common practice. Even if it isn't common practice, it's a good thing to get into. It's a good habit to get into just in case you want to be smart about your things and not risk destroying all your things, maybe. The next one under it is ground. Pin this little 2-bit, that's ground. And then these two, we have the third
Hole.
The third pin down is that's for the positive side of the potentiometer, and underneath it is for the negative side of the potentiometer. Easy enough. You can obviously use any value of potentiometer you want, whichever works best for your project. I find 100Ks to be favorable to start with and really favorable to use. And they're really cheap. You can get them in bulk at Mouser Electronics. I'll put a link to Mouser as well. That's where I get all my components. Super cheap. A lot of fun. Good times. Now starting from the bottom corner right here, we have C, B, and A. Or, if you're looking down it this way, A, B, C to the very bottom.
C.
Now, I don't know the specific details about A, B, or C. I just know that when on their website, under the installation instructions, they said that for most circuit bending applications, it is best to use bridge B and C. And you can do that with anything, man. I usually do it with, oh god, what? I've got some, like, little metal legs that I've snipped off of, like, some LEDs that I've burned out. These make really great little little bridges to connect things with. So yeah, so like on the underside, you can just take it, lay it over lay it over the C and B holes, lay it over the B hole, lay it over the B hole, and then solder it. Just put a little solder on it, man. Keep them together, and then then when you're done, just bend whatever extra bit you don't want, snip it off, and you got a nice little bridge connection there. So I'm gonna put this together, and then we'll see if it works with the cat. Alright, so we've got a pretty solid connection here between B and C. I just used the leg of like an old LED. Pushed it through, bent it, soldered it. I'm sure you saw all that. And this is relatively how it'll look when it's finished with the 1799 chip. So I've got my red and my black. This is positive and negative. Green is pot positive, blue is pot negative, and yellow is out. And it's as easy as that, man. So it's been about a week since I started on the cat. Well, I started technically quite a while ago, but it's been a week since I started doing a video on where I'm at with the cat and just figuring things out. I'm a little stumped. I'm sure you can tell it's been a few days just because my clothes and my appearance have changed. But no, I'm a bit stumped at the moment. I need to figure out what I'm gonna do as far as mounting the potentiometers or anything on it, really, for that matter, because it's got these small side panels, which are great, and they have a lot of depth to them, which normally, if I was to elevate these, I could put potentiometers in it, but they sit perfectly on his side. They're like flush with the actual side that has all the motors and everything else in it. I could take them apart. I'm probably going to, actually, in the next video. I think I'm going to take it apart and see if I could drill some holes in it. And yeah, and maybe I could find some place to put potentiometers, but I think before I get around to putting anything else on it, first I need to find more spots, which it doesn't look like there are that many bend spots on it. I'd still do some more poking and prodding around, but I've only really found 4 at the moment. And it's hard to distinguish exactly what those 4 do, because I don't know, it seems like 2 of them control the motor, and the other 2 control the pitch, but no matter how I wire it, I either get just the motor, just the pitch, the motor and the pitch, or the motor and the pitch. Yeah, so these 4 wires right here are kind of my main points of contacts. This one definitely controls the motor, but when I combine it with the blue one, that does the motor and the pitch, but it crashes a little more often. You know, his sensors aren't as sensory, and he doesn't respond as well when I combine these 2. The green wire, that's a pitch, and the blue one, that's a pitch, and this one seems to be a pitch and a motor, and this one seems to be a motor, and sometimes this is a motor, and sometimes this is a motor, sometimes they're both pitches. I don't know, man, but these are the only spots on the board I can find that actually have any sort of bendability to them. And like I said, I looked at the diagram for the chip. I'll put it, the picture of the chip up here. It's just a DC motor chip, basically. So now that I have the pinout for that, I'm going to experiment more with it and see if I can get in there and find anything really cool that does anything that I would love for it to do or not expect it to do at all. I don't see anywhere on here that hints at any sort of sound bank. If there is one, which there is one because he meows and screams at you, it's under this epoxy blob, and I don't have the patience or the resources or really the care that much. Not that I don't love him, because I do. This is a really cool thing. But it's a lot of work, man. It's like way more risk than reward, and I don't want to break this. Like, I'm happy if I could just control him and get him doing the crazy things that he does, and you know, just keep him as like kind of a familiar, you know, like a wizard pet. I don't know, man. We'll see how this goes. But in the next video, which I am going to be doing this coming week, I have to manage my time a little better. I am going to go a little deeper, and I'm going to see if I can't get these side panels off, maybe screw a few holes into it, load in some potentiometers, maybe a switch or 2, some LEDs. I would love to get LEDs inside of his face. He's got all sorts of, like, I don't know, it's pretty hollow in there, and there's actually, under his forehead, there's this sensor right here, but they're under the rest of it, from what I can see underneath it, there's a lot of room in there where I could put things. Now, I could put the potentiometers on his head. I could just put the little knobby bits on his head, but then that kind of defeats the purpose, because if I have him freaking out and screaming, I'm going to have to keep chasing the knobs all over the place to keep doing adjustments, and I just want something a little more stationary than that. Like, he doesn't get up and, like, walk around, so to say. Well, I don't think he does. I've never tested that side of him before. I don't know. We'll see. But no, thanks for watching, man. Keep an eye out for part 2. Part 2's coming up. I'm going to try and have one of these out every single week. I want to be consistent with it, man. I want to utilize this time to do the things that I love to do, because life's too short to just waste all your time doing stuff that you're not happy doing. And, you know, I enjoy making this stuff, and it's a lot of fun, and I know a lot of people they show interest, at least, even when they don't have to. So, you know, I just thought it'd be really nice to start putting out some videos about, you know, what goes on in the lab, and share some with you guys, because I know that I can learn a lot of things from you guys, which I do. I spend way too many hours on YouTube just, you know, looking for answers to all the questions that I have, or even just watching other people's videos where I sit down and, you know, it's so much nicer to sit down and watch somebody else do something that you're interested in or that you're trying to learn about, because it really gives you a really strong insight on different approaches that people take to it, or you'll notice some things that you didn't really notice before. Like when I was new to circuitry and circuit bending in particular, I stumbled upon like hundreds of videos on YouTube that didn't exactly answer all of the questions I had, or if they did answer it, there was no real like in-depth visual, like watching somebody work on something and watching somebody do something for me to learn from. And then I stumbled upon Ghostfire Electronics. I'll put a link to him in the description as well. And there was a video where it was one of his vlog videos. I'll put a link to the video too, screw it. It's a great video, you should check it out. He's not going through like, it's just kind of like an in-process thing, you know, like he's taking something apart, he's circuit bending a toy, and he's just telling you what he's doing while he's going through the process. He's not like, there are no like specific points that he's trying to make, and there's no like, you know, oh, here's a rhetoric, here's a criteria, here's a criteria of like, you know, oh yeah, so we need to go about through like installing potentiometers and then switches and then LEDs and using resistors so you don't fry all your stuff. It wasn't just that, it was just as easy as just watching somebody work on something, and that itself is way more powerful than a lot of tutorials I've seen. And it was really insightful, and I learned a lot just from watching him work. And I kind of would love to do that for other people as well. Of course, there are some questions that I would love to help answer as I learn, because I'm still learning along as well, you know, as I go along. But I would like to do some things that, you know, a lot of people, I feel, and myself included, could really learn from. For example, soldering to, you know, if you have like a toy that's got those really small SMD chip resistors that are just so fragile that the second you put a soldering iron to it or heat it up, it's just gonna... I'd love to do a video on how I solder to those, because that's exactly what I've done with Helix here, is I've soldered to those little SMD chip resistors, but I have a special way that I do it. And I only knew how to do that after screwing up like, God, maybe 15, 20 toys, just destroying them because the resistor I was trying to solder to just decided to jump ship. So yeah, that's where I'm at right now. So I'm gonna end this incredibly long exit to this video. But no, a lot of good things are gonna happen. I've got him, I've got this big old sassy bass pants. This is another future video. I've gutted him. He's bendable, he's very bendable. He's got those really nice old resistors, you know, the ones that are just like big old thick boys. And I got his spine made out of a, it's just screwed in, like these are keys from like a little piano toy that I tore apart. And I got him screwed in right here. But no, he's gonna be a fun one to do as well. So yeah, that's it. I've also got Atari Punk consoles, 555 timers. I'm gonna put those in some baby heads. Also inspired by Simon the Magpie. He did a video on that, and I thought, man, that'd be so cool. I got many baby heads kicking around, and yeah, so lots of really good stuff coming, man. I'm just gonna try and keep up with it and have fun with it, and just keep having a good time. And I'll see you guys later. Subscribe, do the bell thing, and follow me on all my social media crap. That's it, man. Have a good... take it easy, guys. Take it easy. Take it easy. Take it easy. Get out of here. Go. You're done.